Hello everyone, my name is Federico Melani, he is Martin Orozov. We work for NTT Data and we've been working on SPUNTA project for a couple of years. SPUNTA project is about reconciliation. It's a particular type of reconciliation which is done by all the Italian banks. And this project involves many stakeholders. So there's the Italian Banker Association and ABILAB, which is one of the association's branch, R3, SIA, NTT Data, and Italian banks. And each one of these stakeholders have a particular role. So designing an application which involves potentially all the Italian banks means dealing with all these stakeholders, considering and taking into account all these stakeholders' needs and constraints. For example, obviously the regulator sets some rules that we need to code into the application. SIA provides a particular network which is different from the internet, so we must develop a CORDAPP so that it works on their environment. And of course, there's this SPUNTA process, which is a legacy, an existing process, which is already all the Italian banks have their application for doing this SPUNTA process. And it's a niche old process, but every bank has their own way of doing it, has their own application, and the users are back office users who have been used to do this process in their own ways. So there's not been a standardized process for this. So one of the main challenges was gathering requirements from users and putting them all together, trying to decide which ones were important, which ones were necessary for everyone. And we understood that working with many stakeholders, the key to success is working closely with every stakeholder. For example, in this case, when we got requirements from every bank that says they need some customization, we work closely with the ABILAB to understand how the old process can be redesigned to adapt to the new technology like Corda. So what we did was understand the process, trying to redesign this process as a single standardized distributed application, and trying to get the users to understand that they were working on a distributed application. We also have to deal with compliance. For example, in the POC phase, we tried to create an application and put all the data in Corda, but then now in the production phase we must take into account also GDPR limitations. So we now have to analyze, for example, which data goes into the vault in the Corda ledger or outside. One important thing is that we did not work only on the Corda, but we have to design the complete application also with a Spring Boot web service backend, a batch loading application, and also a front end for the back office users. And also we developed Ansible scripts to manage the deployments and of all these components on various nodes. This is a niche application which is maybe different from the usual Corda use cases, because We have mainly two-party flows. We don't use anonymous parties, and we don't have actual exchange of values, so we don't use outside third-party contracts like cash contracts, obligation contracts, or cash states. But we find Corda is very useful for our use case because we have a lot of agreements between two parties. So, for example, two banks must agree on a specific rule. So we implemented flows to propose and accept a particular rule. We also have many flows that are used to agree on a particular common configuration between banks. And also, we had to implement broadcast in a couple of ways. For example, like a public record of public contacts. We tried, for example, to send the state to many participants, but we found a little problem with that. We also found another implementation.
So basically, instead of having like push the broadcast, each bank stores its own information and then queries all the other banks when it needs their information. So we have a flow that we initiate a flow with each other bank to get its public contact. So this is how we implement the broadcast. So we have the contacts of all the banks. So we cache that on the web service end. Our application, we load huge amounts of data in our database, so we can't just fit everything in a single transaction. So what we do is split in multiple transactions all the financial records, and we cut them in slices and commit a slice at a time. In the end, to make everything atomic, we commit a token, so we know that that particular batch process has complete. And we had some performance problems that we solved. We had checkpointing because committing many slices, like in this way, we create a lot of checkpoints. So we had to solve some performance problems in our application. So the solution is instead of having a list of these slices in Java in memory, we load them in a table. So inside the Corda database, we create a custom table, and we save them there. So our commit flows are idempotent. So they don't have any internal state, but when the slide starts, it retrieves what it has to commit from the database, and then starts committing Corda transactions. We also solved other performance problems by creating tables inside the database. So in our application, we streamlined the way we develop. So we have multiple context in which we interact with our Corda application. By example, we interact through unit tests. We interact using RPC client in our web service, and then we interact with the application through inside the flows. So what we did is we unified the interfaces through which we start flows, query database, get information from the service hub, etc. By unifying these interfaces, we managed to improve our workflow during testing. By example, we have various levels of testing. The first level is unit testing of the flows. So we use a mock network to test them. And then through our unified interfaces, we can use the same functions as if they were scripts to run them when you spin up a node driver. So what we do is spin up a node driver with the nodes, then attach Spring application web clients, and then we can initialize the system and start testing. Moreover, we can use our IDE, Eclipse, as application management console. I mean, we can attach it to real nodes through RPC, and then issue commands like and debug the state of database through our IDE by plugging in this framework we made. Also, this simplifies testing when we're deploying on real nodes. So we have a real network, and to bootstrap it with some data, we can reuse our test logic to populate directly the database of the nodes we are testing. This is an example of the code that we would run anywhere. It doesn't care if it's running through RPC, through Service Hub, or unit test. To start a flow, if you see the CORDAPP.DAO.obligation find all, this is a query. This is an interface to query the obligations we have in our database. Same thing if we see in the bottom, CORDAPP flow cache issue. This is a unified interface to start a flow anywhere. Oh, this is what's the end of what we obtain with our framework. Okay, this is the UML of our facade. So we put everything in behind the interface. So this is shared everywhere. So this interface has the functions to get, for example, the party of the node that is connected to, or we have then the flow facade when we keep all of our top-level flows. Then we have the hub, which wraps the Corda functionality that are in the service hub. So we can call them through RPC or through service hub in the same way. Then we have the DAO, where we hold our DAOs. And finally, we have services where these are the CORDAPP functions. We put our business logic there, which uses only the other functions exposed by this interface. So we can we have moved most of our business logic inside our CORDAPP. So this can be easily tested, or we can, if you issue a command to the facade, we can bootstrap a test network. Then we have pre-implementation of this facade. One we would create through the Corda facade RPC that we would create in our web service client. It's Corda RPC Ops. Then we have the one CORDAPP facade flow that will be initialized inside the flow, by example, to access our DAOs or the hub. And then we have the CORDAPP facade test, which is the one we would initialize inside our testing environments. Okay, this is the reason why we decided to unify the interfaces. In the first function, this is how to execute a vault query through the RPC proxy. We'd have to get the proxy and then call the function vault query by criteria, and then we put the criteria and class. Underneath it, we have the same function, but if we call it through the service hub, you see that the name of the entry point is different, the method name is different, and then in Java, even the order is it's mixed. So by our interface unifies those. Moreover, during testing, we would have to wrap native queries in a transaction. Through our wrapping classes, only during tests, we wrap our queries in a transaction. Okay, this is the schema of, this is the UML of our DAOs. So you see the CORDAPP facade that I described in the previous slides. We navigate to the DAO facade, which holds our DAOs, it's just a container. And there we have the base DAO, which has all the utility functions like find all states, find by participants, etc. Other DAOs inherit from it. And we achieve the flexibility by using the bridge pattern. This is like a standard design pattern, like Gang of 4. And this hides the various implementations. We have 3 implementations, like the one through the RPC, the one from the service hub, and during testing. So the test service hub DAO bridge would hide what we saw before, it wraps transactions. Moreover, through RPC, we don't have access to the, we can't make native queries. So This has a structure that it would start a flow just to execute the native query inside it and return the result. So through the same interface, we can also make native queries through RPC. This is an example of our DAO. As we see, we write the criteria just once. It's not scattered on the client and then on the client side and then inside the service inside the CORDAPP flows. This is in this component we specify the criteria once and then use it everywhere. This is an example of a native query. As before, we just write the string once of the native query and then start it to the query interface underneath. Okay, in case of RPC, as I said before, it will start a flow to execute the query and then return. And here comes the most, complex part of a small framework. We see CORDAPP FACADE as before. It has the flow, the flow function, which will give our flow container. It has all the top level flows in it, those that are normally started by RPC. This structure also help us to start flows through RPC in a less error-prone way, because normally when you start flow dynamic, you would have to specify the class and then a series of arguments. In this way, if we use the FACADE, it's impossible to get it wrong because it's strongly typed. To achieve this, we have this bridgeable flow interface. Our flows implemented is just an interface, which has two functions: get the flow class, which will give the class of the initiator flow, and then its arguments, which are those that we pass to the constructor. Since this is an interface, our flow can inherit any flow logic we want. It's not binding. So we see that issue obligation initiator implements that interface. So we do something similar to our DAOs. We use the bridge pattern again. So in the flow FACADE, it hides all the various implementation. We have various flavors of flow FACADEs. There we have synchronous, asynchronous. So we would use, by example, the asynchronous one in our regular web service, and all the others are using during testing. So if you're using this FACADE to execute a script that runs instructions to real nodes, we would want them to be synchronous and wait for the flows to finish before proceeding with the next step. Moreover, in the Flow Bridge Test Service Hub, we test the bridgeable flow because it simulates a call as if it were start flow dynamic. So it will use the get class and the get arguments, and it will fail early during flow test instead of failing when we do a client call. If we implemented get arguments or get flows wrong, we will catch that error early. And this is an example of our one of the bridges. As we see, it accepts a flow and any flow that extends flow logic and our interface. Then start flow dynamic, we pass the class, the arguments, and then return the Corda future. Okay, this structure is also applicable to flows that we don't have control on, like the cache issue flow. So what we would do is make an adapter that will implement the bridgeable flow and have the arguments we would pass to the cache issue flow. And in the get class flow, we will put the cache issue flow directly instead of the instead of the adapter. So when we call this, it will call directly the adapted flow. And this is an example of how we would use our structure in unit test. So in the second line, as service self-issue cache, this will call our service and will generate cache. And then we would start a flow and run a flow by issue obligation. So this code is usable in all the contexts, tests, flows, node drivers, etc. This is what we would get when we use the IDE as administration console. These nodes would be attached through real RPC proxies, and we can query and debug the database. In our production-bound application, we isolated as much as code as possible in order to not repeat ourselves and write same logic many times. We put everything on separate tables instead of keeping in objects in our flows.
Also about requirements and design, we learned that adapting an old process into a Corda application requires a lot of effort in requirements and design, because we must not consider just the Corda but the whole application itself.
And that's it.
Thank you.
Thank you.
So we've got one question on the app, which is how much of your testing framework did you have to write from scratch, and how much already existed in the Corda distribution which you could reuse?
We started from scratch, actually. Yeah.
Well, we use the mock network and obviously the Corda framework. But
so basically, we write unit tests only once for a mock network, and we can use those tests as if they were like scripts, so we can run them on other environments beside mock networks.
Thank you. Do we have any questions in the room? Because we have a minute. Yeah.
Do you write these facades manually, or do you use like some kind of like reflection techniques to, or do you write each one?
Oh, I mean, you mean the marker for the flow?
Yeah, so like, you know, the bridgeable flows, and like you would call it.
Yes, it's absolutely. We can surely do it by reflection instead of inheriting that flow. This is the version we have at the moment, but surely it can be done with reflection. We might, yeah, it's doable. So, but it's easier to explain this way.
I think we had another question.
Did you use any kind of testing framework or out of the box, or did you create one internally?
We're using the JUnit with the flow tests with the mock network.
We've got another question on the app, which is what features do you think Corda could add to reduce the testing effort?
We had some performance problems, because we have our unit test packages. If we run all unit tests, it takes like 2 hours to run them all, because for example, for each method we create the mock network, and after the test we destroy the mock network. So maybe this can be done a little faster.
All right, thank you. Could we get another round of applause?